George and the Big Bang by Lucy and Stephen Hawking. Chapter 12. George shot out of the other end of the tunnel, skidding face down along a stretch of bare rock. His vision was still blurry from the bright, swirling lights of the silvery tunnel. For a second he saw stars before his eyes. Then he lifted his head and saw thousands more of them, burning redly in the black sky around him. As he peered off, he saw something else. A large black boat appeared in front of him, and then another. George rolled over and looked up at a figure in a black spacesuit looming over him. Its face hidden by the darkened glass of the space helmet. It didn't make any difference. George didn't need to see his features to know that this was Dr. Riffer. The dwarfed scientist and madman was on the loose in the universe once more. Behind Ripper's head there was an immense expanse of sky, so dark that his shape seemed to blend into it. Beside him, George could see nothing but bare grey rock pitted with the great craters. He struggled to sit up, his muscles jelly-filled by the journey. "You can stand," said Riffer dryly. "I pick an asteroid with enough mass that you wouldn't float off." When George had landed on a comet on his first space journey with Annie, they had to teach themselves to the potato-shaped ball of rock and the ice because its gravitational force was not strong enough to keep them on the surface. While the comet had been mostly dust, ice, and frozen gas, this asteroid was bigger and made from much denser materials. The gravity here seemed to be holding George firmly in place. "Where are we?" he wondered, staggering a little as he got to his feet. "Don't see anything you recognize?" asked Riffer. "No lovely blue-green planet hanging in the distance, just waiting for you to save it." George could see nothing but stars. The mouth of the tunnels had disappeared entirely, leaving him no escape from Riffer and this strange rocky place. "Of course you don't," continued Riffer. "You won't recognize much of your own galaxy if I'd taken you out into the Milky Way. But you are no longer in your home galaxy. You've journeyed farther than even more." "Are we in another universe?" asked George. "Was that a wormhole?" "No," said Riffer. "That's my updated version of the portal. A doorway seems terribly old school, don't you think? Eric always was such a traditionalist. You wouldn't think it, would you? His theories told of everything we thought we knew about the universe, and yet, when it comes to designing a portal, he models it on his own front door. This, George, is Andromeda." Andromeda. Andromeda Galaxy, also known as M31, is the nearest large galaxy to our own Milky Way, and together they are the largest object in our local group of galaxies. The local group is a group of at least 40 nearby galaxies that are strongly influenced by each other's gravity. At 2.5 million light years away, Andromeda is not actually the closest galaxy to us. That title probably goes to the Canis Major Dwarf Galaxy, but is the closest with a comparable size and mass. Current estimates suggest that the Milky Way has more mass, including dark matter, but Andromeda was more stars. Andromeda has a spiral shape like the Milky Way. Like a Milky Way, Andromeda has a supermassive black hole at its center. Also, like a Milky Way, Andromeda has several, at least 14, satellites to dwarf galaxies in orbit around it. Like most galaxies, light received from Andromeda is blue shift. This is because the expansion of the universe, which makes the galaxies move away from each other, is being overcome by the gravity between the two galaxies, and Andromeda is falling down toward the Milky Way at around 300 kilometers per second, 186 miles per second. The two galaxies may collide in around 4.5 billion years and eventually merge, or they may just miss. Collisions between galaxies are thought not to be usual. The small Canis major dwarf galaxies appear to be merging with the Milky Way right now. Another galaxy, said George in awe. Our neighbor, confirmed River, swayed an arm around him. This is, if you like, the galaxy equivalent of the stars next door. Given the size of the universe, it might as well be. Notice anything? The stars look the same, said George slowly. This asteroid looks like an asteroid. I suppose we must be orbiting stars, so we're in another solar system. It's not so very different from being in a Milky Way. Yes, indeed, agreed River. Remarkable, isn't it? Close up, no two pieces of rocks are exactly the same. No two planets, no stars, no two galaxies. Some regions of space contains just clouds of gas and dark matters. But in other places you find stars, asteroids, and planets. So much very. Yeah, here we are, 2.5 million light years away from Earth, and things don't look that different. This asteroid could be in our own solar system. Those stars could be in our own Milky Way. The variation here are the same as in our own galaxy. What do you think that means, George? Answer me that, and I'll tell you why we are here. It means, said George, thinking about Eric's lecture, that everything everywhere was formed in the same way, from the same material and by the same rules, but the tiny fluctuations and the beginning of the time caused everything to turn out a little bit different from everything else. Uniformity in space. In order to apply the general reality to the universe as a whole, we usually make some assumption. Every location in space should behave in the same way, homogeneity, and every direction in space should look the same, entropy. This leads to the picture of the universe that is uniform in space, starts with a Big Bang, and then expands equally everywhere. This picture is strongly supported by astronomical observation, what we can see in space telescopes on the ground and in space. Yet the universe can't be exactly uniform in space, because this would mean that structures like galaxies, stars, solar system, planet, and people couldn't exist. A pattern of tiny ripples over the uniformity is needed to explain how the first fractions of gas and dark matter could begin to collapse, so that the laws of pieces could go on to create stars and planets. Because the gas and the dark matter start out nearly uniform, and because we believe the same laws of pieces everywhere, we accept that all galaxies form in a similar way. So Distant galaxies should have similar types of stars, planets, asteroids, and comets to those that we can see in our own Milky Way. Where the internal tiny ripples came from is not yet completely understood. The best theory at the moment is that they came from the microscopic quantum jitters that were managed by uh, a very rapid early expansion chase called inflation that took place during a very tiny fraction of the first second after the Big Bang. Well done! I am glad to know that one of my spoofs at least can show that he has benefited from his education. Why have you brought me here? Asked George bravely. What is this time? I don't think I like your tone. River now sounded more like he had when he'd been a teacher at George's old school. I don't think I like being catapulted into space by a talking hamster. George shot back at him. Of course, said River hastily. I can see that was a bit of a surprise, but I had no other way of correcting you. Oh, really? Said George. Didn't you break into my house at night and leave a note in my school book? Yes, I did, said River. Now he seemed unusually nervous, like the River of old was always totally confident of his evil powers. I was trying to attract your attention. I couldn't find Eric next door, so I came and left a note for you instead. Why didn't you just come and talk to me? If it wasn't so important? Because I can't, said River in frustration. I can't go anywhere or do anything. I'm trapped. Since I slipped away to your houses late overnight, they put me under even closer surveillance. They don't know I visit you, but they know I went somewhere and it has made them suspicious. That's why I had to meet in you in space. It's the only safe place for us to talk. I couldn't possibly have contacted you, and certainly not by earthly means. I would have blown our only chance or stopped them. Who is it who's watching you? Asked George. Damn, said River. Toe rag. They are everywhere. He looked around as he spoke, as though they might be floating past the asteroid in the unknown part of the Andromeda Galaxy. These there are the unseen, the dark force. They are all around us. I think that's dark matter you're thinking of, said George. The invisible material that makes up 23% of the known universe. George said, referred earnestly. "Mm, You are so right. They are humanity dark matter. You can't see them, but you know they are thereby the effect they have on the universe around him. For once, he seemed to be speaking from the heart, if indeed he actually had one. When the people in black at Eric's lecture, demanded George. There was a few of them. Here are many more. They are the best network. I was there too at the demonstration. I couldn't get near you, so I tried to alert your Dia that the boy couldn't work. I knew it, said George. I knew it was you, but I couldn't work out why. I don't understand why Tarek is doing this. Why would it be so bad if Eric discovered the theory of everything? Why? Why would it be so dangerous to understand the origins of the universe? For you and me, it would be a great step toward. For Torek, it would be terrible. One thing blue. Because the true Bakun, mm, as George, and what am I too? The leaders don't really believe that the universe will be drift apart in a glowing bubble of destruction, leaked by leaked from the larger hardened collider. Refer told that used the front refer to them. That's just a terrible personally epitic in perspective so that their network keeps on growing. They what they're really scared of it's something very different, such as the asteroid is sped onward on its orbit, circling a very bright young star that was a few billion years younger than our sun. As George watched 200-yard long chunk of rock smashed into into George over order with energy of a nuclear explosion. A cloud of pulverized dust expanded outward. This young solar system was a very violent place, with many such chunks hurtling around the central star. Eventually, planets would form, and the vacuums of all the debris left lying around all after these collisions.